Good evening. My name's Tom Giroux, and I'm with the Forest History Association of Wisconsin. I'm on the board of directors, and this is one of our webinars that we're going to be doing. And before we get into our program tonight, I just wanted to tell you a little bit about the Forest History Association of Wisconsin. You can see our mission up there, which is to inform, educate, archive, and publish. Certainly, these webinars are part of our Inform and Educate mission. We also have some archival materials on the forest history of Wisconsin in Stevens Point, and we publish the proceedings of our meetings. So we have lots of information to share with people. I would encourage you to check out our membership page. It's relatively affordable at $20 per year. And we'd appreciate the support, any support you would give us. These webinars are free because they're part of our mission, but we'd welcome you as a member if you'd want to join. So with me tonight is Donald Schnitzler, or we affectionately call him Schnitz, and he's going to tell you a little bit about how the program will proceed tonight.
Okay, as Tom said, my name is Schnitz, and I am a member of the Board of Directors of the Forest History Association of Wisconsin also. I'm pleased to welcome everybody to tonight's presentation, our November 2024 webinar. To help make this a successful experience for everyone involved, we're going to ask you to pose questions using the chat feature, which is probably located at the lower part of your screen. You can put the question in anytime during the presentation, but we will hold the questions until the end of the presentation when either Tom or I will relay them to our speaker. If you're new to Zoom or have any challenges as you're listening tonight, you can use that same chat feature to reach out to Tom or I, and we can see what we can do to fix any problems you might have. And finally, after the webinar is over tonight, you're going to receive a brief 7 or 8 question survey about the webinar. We'd appreciate if you take just a few moments and fill that survey in for us. We'll use it to plan future webinars and also provide feedback to our speaker. The presentation for tonight is called Taking the Long View, Fire, Climate Change, and Forest Resilience in the Lake States. Historically, fire was central in creating and maintaining an array of native communities in the Lake States, and fire remains a critical management tool. Much of what we know of fire maintained systems stem from European settlement, General Land Office survey records, and other historical accounts. While incredibly valuable, these accounts are often sparse and limited temporarily, static in time, and spatially, coarse resolution. To sharpen fire as a management tool, we need greater depth of understanding in historical fire, as well as what that means for its current application for particular management objectives. Our speaker tonight is Jed Meunier, an ecologist and research scientist with the Wisconsin Department of Natural Resources. One of his main interests and expertise is in fire ecology and using natural disturbances for guiding management and restoration through integrated approaches aimed at understanding mechanisms for ecosystem changes across scales through applied research. We're looking forward to learning more about fire, climate change, and forest resilience in the Lake States tonight. So I'm pleased to welcome our speaker, Jed Meunier, for this evening's presentation. Jed, the platform is yours.
Okay, thank you, Don. Let me see if I can get this going. And I will hit the share button this time. So you should be looking at my title screen. Does that look about right?
Looks good.
Okay. Well, great. Thanks for having me, and it's good to be here. I think this is a great format on a night like this where it's starting to turn winter finally in Madison, at least where I'm located. So I just want to kind of stay at a high level for a little bit and give some sort of basic background information setting up this talk. I'm going to speak more specifically about some of my fire history research on historical fire regimes. And then I want to try to bring that all back into, well, what does it mean? Kind of the so what. And this to me is a really good starting point. There have been various state of the bird reports of the birds of North America. This is one of several. They basically all are telling us the same thing, and that is we've got a big problem on our hands. Our problem is not anymore just keeping threatened and endangered or rare species on the landscape, but keeping common species common, which is becoming a problem. Um, and I put this Leopold quote in here, and I just want to read it quickly. He writes, "The object is to portray the mechanism which produces all species on all lands, rather than to prescribe the procedures for producing particular species or managing particular lands." And one of the reasons I really like this quote is because, this is 1933 in what is arguably the very first textbook on game management at a time when wildlife was still two words. And in this textbook on game management, he's telling us to think big and creatively and across all lands and across all organisms. And sort of staying broad still, this is a picture, and I apologize because even when it's not projected, it's a bit grainy, but I really like it. It's a picture of the Upper Peninsula of Michigan, and hopefully you can make out, if you can see my mouse, there's a few individuals standing next to these charred bowls, these trees. And then if highlighted now are these basal injuries at the base of these trees. This is a mixed conifer forest in the Upper Peninsula. And with these basal injuries, the only time you see these in a forest is when you have relatively frequent low severity fire regimes. So it's absolutely indicative of frequent fire of low severity. So these trees get injured but survive, and they record these fire events over time. And I will tell you more about that when I get into my own work. But it's kind of academic whether this is quote unquote a woodland or a savanna or a forest in terms of its structural density. We academics like to talk about those things. According to some of those definitions, I've spent way too much time looking at this photo, counting the number of stems, estimating the area, but this is solidly a forest. And so what we are looking at is a very, very open, fire maintained mixed conifer forest right here in the Lake States. And I think this part of the story most of us know well, right? And that is that, when Europeans came over and settled this continent, this country, and I just, as a backtrack for a minute, I'm using the term settlement or European settlement really to describe, it's a pretty gentle term to describe a rather violent episode in our history in terms of both people and land. So just forgive that nomenclature a little bit. But this period of European settlement, as we know, was marked by drastic changes. We basically cut over our forests before we had much of a chance to understand forests, like in that previous photo I showed you. The photos you're looking at here, the one on the top left is in Minnesota, and that's still the early river lumbering days. So initially, before we connected railroads and were able to move hardwoods and other lumber further from rivers, we were primarily stacking softwoods, conifers on the side of these streams and waiting for high water, sometimes helping them along with dams and dynamite and other methods. So that's the early days of river lumbering. And the other part of the story that I think is really important, and it's very, we really led the country in this, is following those cutover forests, we had really large, often destructive wildfires. The picture on the bottom right is after the 1894 Hinckley, Minnesota fire, and they're exhuming the dead. It was probably the most destructive fire in Minnesota's history. Interestingly, 1894, in Phillips, Wisconsin, around that region, we had several hundred people die as it burned over that country as well here in Wisconsin. So many of these fires were not just destructive in one area, but they were widespread across the Lake States. And I've got just a few of them listed here. So really what I'm telling you is that these things often go hand in hand. The story is we cut down our pines, we had all this pine slash, we had fuels for these large fires, and the fires were often destructive. So we had to do something about that. This is what's termed the Sargent map. It was published in 1884, and this map was really it was really commissioned to try to get an understanding of the magnitude of the problem that we had to fix. So we knew we had a problem with wildfires. This was a snapshot of what that looked like in 1880. And so this really was used to justify a new emphasis on fire control nationally. And what you'll notice is one, the eastern United States really lights up in this map, especially the southeast, where there's lots of, where there was lots of burning. I would say that most of the areas that are not colored in on this map are probably grasslands, and they were burning too. So really, we are a country that could and can burn and did. And to do something about that, long before Smokey Bear, one of the campaigns to sort of try to stamp out this practice of woods burning was focused in the south, in the deep south of the U.S., called the Dixie Crusaders. And so this was in the 20s to about 1931, and it was the American Forestry Association launched this big project, and they had multiple parades collectively traveling hundreds of thousands of miles, weaving throughout the Southwest, showing picture films. They hired psychiatrists to understand human behavior of woods burning. They handed out pamphlets. They showed movies, oftentimes in communities that didn't even have electricity or hadn't heard radio. And so this was a big effort to try to stamp out this practice, and it was effective. It's estimated in 1925 in the Southeast, 21 million acres a year were burning. And by 1965, that was down to 600,000 acres. And I should also point out, this era was marked by the Clark-McNeary Act, which tied federal funds to states to eliminating controlled burning. So there was federal legislation, and we were getting serious about fire control. And this wasn't just limited to the Southeast or the South. The figure that I'm showing you, the graph, is by Greg Nowacki and Mark Abrams. It's their best estimate of kind of the similar trend in the decline of acres right here in the Northeast and Midwest. And so I think what's important to realize about this, though, is if we think about the origins, certainly of forestry, but also really conservation in this country, they're really based on getting a handle on this wildfire problem. So it was about stopping fires. And on the other hand, or the other part of it, was about restoring or planting back what we'd sort of devastated or leveled, at least when we with the Great Cutover. And so fire suppression and tree planting are really the roots of forestry. And when I say they're the roots of conservation, we have the 1924 Clark-McNeary Act that I mentioned. We've got the 1911 Weeks Act. All of this was about organizing fire suppression, but some of the very first laws to come out of that was dealing with slash in the woods. So this was our effort at quote unquote conservation. And then, underlying these things was this strong sort of successional theory underpinning. So this Clementsian, early successional all the way down to climax. And so that's really if you had to put forestry certainly in a nutshell, I think you would be hard pressed to find three things that sort of describe that nutshell better than those three things: fire suppression, tree planting, and successional theory. And in many cases, we have not gone very far away from that agricultural model. These are pictures not from oil palm plantations in Brazil. They're from Wisconsin. The picture on the left is actually, I have Bob Hansen on that. That might actually be a friend of mine, Mike Amon. We were just talking about this, but Mike Amon, Bob Hansen, and others are trying to do sharp-tailed grouse restoration up in the northwest sands of Wisconsin. And so that burned area is the core sharp-tail area. So they're starting to cut down some of those plantations. But I really like the photo because it shows the miles and miles and miles of furrowed ground for planting pines. And it's really what we still do today. Most of our pine is plantation, so it's not natural origin, and most of it is in straight rows after furrowing and maybe herbicides. And so if we look at what Jerry Franklin, who's sort of the guru of old growth forestry and a really interesting guy from the Pacific Northwest, Jerry writes, there are even fewer absolutes in ecology than forestry, but an emerging operatum maxim is simplification is rarely beneficial. So what I'm telling you here is that, this is the epitome, frankly, of simplification. Fast forward to the present, and we're starting to understand forests and systems differently because we're being forced to reckon with them differently. This is the pie graph here is from a fairly recent Forest Stewards Guild logging survey, where they surveyed loggers from all over, asking like what matters in quality logging operations. And so, on one hand, I would argue that we wouldn't see these labels, or these portions of the pie would have been very different 5 years ago, certainly 10 years ago. The other thing I would argue, if we think about them, improving forest resilience, reducing wildfire threats, diverse habitat, carbon, I would argue that in order to really understand any of those pieces of that pie, we also have to understand our disturbance ecology and historical fire. And so Derek Churchill, who's one of Jerry Franklin's students, has written that there's broad consensus that to increase resilience, we have to seek the range of patterns found in forests with intact disturbance regimes. And this is really, really fundamental and critical. Okay, so what do we know about disturbance models in this region? So as Don may have mentioned in the introduction, really a lot of what we know comes from a really wonderful data set. It's the very first General Land Office Public Land Survey. And so what this was it was basically gridding the entire country. And in Wisconsin, that occurred roughly around 1832 in the southern part of the state and proceeded northward mostly. And by 1866, it was mostly completed. And what the surveyors had to do essentially was, in order to privatize the public domain, we had to know what we had as a country. And so they developed this system of township, range, and section that maybe we've heard of or sounds familiar. And in doing so, in surveying the land, as they went out and sort of gridded up the landscape into township, range, and section, they took note of witness trees. So from each section corner, they would take note in a different quadrat of the nearest witness tree, and then they would take the distance in azimuth to that tree. And if they couldn't find one, they had to make a rock pile or some other monument. So it was much more efficient to use a tree. And sometimes you can still see occasionally on some of the longer lived trees when they scribed in the section onto the corner trees. But anyways, the survey was really not for ecological purposes, but we've mined that data repeatedly for all sorts of things. And so here's a map put together by Dave Mladenoff at University of Wisconsin and others that basically shows sort of the species, all those different witness trees around Wisconsin. And so when we analyze that data, we can ask, for example, the proportion of trees in those GLO notes that were coniferous, hemlock or white pine, and we can compare that to today's forest inventory. And so we know, for example, that 22% of the landscape was comprised of hemlock and pine, and now that's basically 1% of the landscape. Things like that. And here's another, Lisa Schulte Moore, who also worked with Dave Mladenoff, has written about this. And what we know is that we still have forests, and we still have our 3 native pine species, jack pine, white pine, and red pine, but they are nowhere near as abundant as they were. Most of those species are, again, in those straight rows that I showed you. And we just our forests just haven't recovered really since that cutover event. And another way that the General Land Office notes have been used is to try to estimate disturbance regimes or to try to determine them. And so Lisa and David, for example, have done so using the General Land Office notes in Wisconsin. And basically, if you've taken a forest ecology class in probably the lake states in the last 40 or 50 years, you've probably learned about the importance of wind. And sometimes those wind events were followed by fire. This is sort of this is getting a bit nuanced, but they also calculated rotation periods for fire and wind, and this is really I'll just give you a definition here. So you'll hear me later talk about mean fire return intervals, and that's the time between fire events at a particular spot. If we want to talk about a landscape, so in this the picture of northern Wisconsin, it's divvied up into similar ecoregions or subregions based on geology, substrate, soils, forest, etc. And so what we can say is if we take like that JM, which is the Northern Highlands, we can ask, how long would it take for fire to burn an area equivalent to that area? And what I mean by that, some parts of the Northern Highlands might burn 10 times, others not at all. But within that landscape, how long would it take to burn an area equivalent to the entire landscape? That's a rotation period. And what you see are really, really long rotation periods ranging from 700 to 93,000 years was the longest fire rotation period that they calculated. And I just want to repeat, or I just want to pause on that number for 1 second. 12,000 years ago, the entire portion of that map, or 15,000 years ago, was under 2 miles of ice, probably. 93,000 years was the longest rotation interval. And so, and as we think about this in terms of our forest, so on the picture on the left, we have a natural origin red pine stand. The one on the right is familiar. It's a pine plantation, also red pine. And really what we've learned from, from the models that from the General Land Office notes and other types of data like that, these long rotation intervals, basically what we've estimated is that these types of systems had infrequent but punctuated mortality followed by punctuated recruitment. So in other words, these stands are simple, they're generally even aged, and they're homogeneous. And they largely came about after a severe disturbance, and which also regenerated the stand. So in some ways, if you think about that, then what Derek Churchill has written, restoring the range of patterns found with intact disturbance regimes, well, maybe we're not too far off here. And so in essence, we manage pine plantations and natural origin pine exactly the same. And it's density-based thinning. It's giving, the chosen trees that we select maximum space. And to do that across a forest, you basically end up with regularity. Homogeneity is another word. And this is where my work comes in. I've been finding, I mentioned those basal injuries that we see on trees that are indicative of low severity but frequent fire. This is what I do. I do tree ring work among many other things. These are sort of pictures of what that business looks like. And really what it's based in, dendrochronology, dendro meaning tree, chronology is the study of time. So literally the study of time through trees or tree rings. And it's important to note, so if I find an old stump in the woods, sometimes that stump was cut 150 years ago, but there's enough of it left that I'm able to take a piece of it. And if I have 100 rings or more, I'm usually able to cross date it. And the way we do that is we basically memorize patterns of drought over millennia. So if you have a really old living tree that overlaps with the more recently dead one, with a longer dead one, et cetera, and we can build these chronologies. I have 800 years of fire history, maybe even more than that for tree ring data for the lake states. And when we think about chronologies of tree rings generally from sequoias and bristlecones and other species, we have chronologies like this that go back 10,000 years or more. So this map is somewhat dated, but each one of these pins is one of my study sites where I've sampled numerous stands and collected fire history data and some other kinds of data that I'll share. I'm not going to talk about all of these, but I'll talk about the types of data that we're collecting and what we're finding briefly. And so one of these pins, for example, is the Togatik River in the Northwest Sands. And so these fire history diagrams, which are those horizontal lines with the triangles, what you're looking at there is each one of those horizontal lines is an individual tree, usually a stump that was cut. And we're able to take a piece of that stump, bring it back to the lab, polish it up, cross-date it, and then figure out, each one of these fire events, which is those inverted triangles. Occasionally, we have a recently dead tree, a snag, or even a living tree we can get a partial section from. But essentially, those are all samples, and then those are all the fires. Now, the important thing here, let's see if I can use my mouse. This down here, the dates, are what we call a composite. And so in this case, I've asked the program that I use to show me only the dates for the fires that are replicated on at least 2 samples and scarred 25% or more of the samples in the whole chronology. So basically, they have to be replicated. And really, we can change that composite to be whatever we want. More and more restrictive means bigger and bigger fires within a site and oftentimes across sites. And so with that in mind, this composite, what we're able to determine here is that, this site was burning on average every 7 years. And then the bottom graph down here, Pinus resinosa, pyri, which is red pine, white pine, and this is deciduous, lumped. And what you see there is that these dark bars, that's red pine. And so red pine, to even call this a cohort, because it occurred basically over a period of 50 or more years, I'm not even sure that is a cohort. So essentially, we basically have continual recruitment. These are trees. Recruitment means the pith date of a tree, when that tree was established, basically born into that stand. And so what we see is that we have continual recruitment and we have continual disturbance. So we have muted recruitment in the presence of those low severity fires, but continual. So in essence, it's the exact opposite of what I just told you, how we conceptualize, think about, manage pine systems in the lake states. Completely opposite. And so this is a subset of the sites that I showed you, those pins, 8 of them, 2 in each sort of ecological region of the Northeast Sands, Northern Highlands, Northwest, and I guess also the Central Sands. And so in these sites, we collected really intensive data. And so what we were able to determine here with this data is I'm basically just showing you, we took cores from all the living trees and we dated all the dead material and we grew those stands back in time. And basically, circa 1860, we're able to calculate the density of the stands at that time versus now. And maybe it's no surprise, it probably shouldn't be, but what I think is important to know here is these are some of our best of the best. These are our old growth sites. These are, some of our nicest natural origin red pine stands anywhere. And so what they are today is on average 12 times more dense than they were historically. The other thing I'll point out, and this admittedly is a bit nerdy, this is academic, but it's really, really important. So I'm going to just kind of, I'm going to try to belabor this as best I can, but essentially we put these half-hectare plots in. And so in this case, this half-hectare plot was broken up into 4 quadrats, and we stem mapped. We took the spatial location of all the trees, and then we took cores of all the trees and stumps and et cetera, and grew them back in time, like I just mentioned. But now what we're looking at is not the density as a whole, but we're looking at the spatial patterning. And so this is a spatial analysis that looks at that patterning. And basically, this red line is what we expect. This is completely spatially random. And when you're above the line, and then the gray area is our confidence envelope. And so that's our statistics. If we're above that, then the trees were clustered. If they're in this gray area, they're spatially random, and if they're below, they're disaggregated. But essentially, for everywhere we look today, this is our forest. They're completely spatially random. And when we grow those stands back in time and look at their distribution, they are almost always clumpy groupy. That's my word for clustered. So really, really different spatial patterning. And so I've grabbed some pictures by Andrew Larson, another one of Jerry Franklin's students. And so and the applicability of this is numerous, but maybe the simplest way to think about this is, even if we're using public taxpayer dollars in many cases for hazardous fuels mitigation projects all over the country, especially out west. And even with enough wind, this homogeneous forest can sustain crown fire, whereas it's virtually impossible based on empirical data, wildfires that we've watched, and from modeling to get crown fire, to sustain crown fire with a clumpy, groupy spatial pattern where you have small, medium, large openings, scattered trees, etc. And so you may have the same number of trees, the same basal area, but their configuration has really, really important ramifications. Whoops. Okay, back on. All right. So I hope that didn't confuse you too much, but I'll try to come back to that. And so using our own data, low severity fires, for example, we calculated rotation intervals. Remember now, rotation is a spatial statistic for fire. Basically, how long would it take to burn, in this case, the entire Northern Highlands, right? And we estimate with low severity fire, it would take 34 years to burn the entire landscape. And that's compared to basically 3,000 to 4,000 years. So we're talking orders of magnitude difference. And so I told you about compositing those fire history graphs. So we can basically say, show us bigger and bigger fire events. Well, now I've taken the composite. So I've said, show me the biggest fires within a site. So now 30 trees make up a single one of these lines. And then I said, show me only the biggest fires that occur within that site. And now I've done excuse me, I'm drawing on the wrong one. What this composite's telling us is I've asked it to show me fires that were synchronous across multiple ecological landscapes. So it's kind of like a double composite. And this is that data from those 8 more intensive sites. And now if you look at these dates, I'm hoping that, if you guys were all 15-year-olds, I know I could ask you to tell me about some of them and you'd be shouting out one of them in particular. But since this is a virtual event and most of you maybe aren't 15, we'll skip that. And so I'll highlight a couple of them. So 1910, as an example, was the largest fire year known in modern history in the Northern Rockies. It's the story that made Ed Pulaski famous for holding his crew by gunpoint down in a mine shaft and saving their lives. It's basically the fire that built the Forest Service as we know it today. And then there are a couple others I have highlighted there too. One of them is 1780. And what's cool about 1780 is that there are records of this fire, the fires burning across the Lake States in Ontario and Canada. And what happened was, and we can probably relate to this after last summer, 2023 Canada fires, but the weather conditions were such that the sun was blotted out in the middle of the day on the eastern seaboard, and really nobody knew why, because it wasn't accompanied yet by smoke or ash. And so the sun just went black. Chickens were going to roost. People were going to church. They thought it was the second coming of Christ. Nobody really knew what was going on. And eventually later in the day, the smoke, the ash, everything else came with it. And I think it dumped about 3 inches of ash over several states. So these were big fires burning throughout the Lake States in Ontario. And it's kind of cool because it's corroborated in papers on the eastern seaboard. And so the 15-year-olds in the room were shouting, the Peshtigo fire, the Peshtigo fire. So that was a October fire of 1871. And so that, again, here's another one of these fire years that's showing up in the fire history chronologies that I'm putting together. And what I'll just remind you is that when what I'm talking about, what fire scars collect, what they are records of low severity fires. Those are trees that lived through those fires, weren't killed. And when you look at this map of the burnt district of 1871, what's now the Menominee Indian Reservation, we find low severity fires that burned. What is now Marinette and Oconto counties, we find the evidence of those low severity fires all through there. And what we usually think of as the Peshtigo fire is this 1.2 million acres of high severity fire. And so there's multiple things that are really interesting here. One is that, where there was pine slash, presumably, we had low severity fires. The other is really just the underestimating of the area, the difference between high severity and low severity. And I got interested in this in part because I'd find maps like this one. And so if you look at this 1.2 million acres of high severity fire, you see the place names are Upper, Middle, Lower Sugarbush, Birch Creek. For those of you who know Door County or know Green Bay, know this area of the state, you probably could predict what I found when I pulled out the General Land Office notes. That is that there's very little pine in that country. It is a very mesic forest. The number one, so I pulled the General Land Office notes out. This again is those settlement era witness trees. And in this 1.2 million acres, there were just over 11,000 of those witness trees. The majority of them were hemlock, followed by cedar, beech, tamarack, sugar maple, white pine, black ash. I mean, there was some red pine in there, but very little. White pine is also really indicative of more mesic forests often. But anyways, it's fascinating to me. And again, in 1871, the railroad hadn't quite yet linked Peshtigo, Wisconsin, or this region with Green Bay and the rest of the world. And so we were still river lumbering. We weren't going deep into the bush. Now, that isn't to say there wasn't all kinds of European settlement happening, land clearing for that. But the usual story that we like to tell of, the cutover, the pine slash, the anomalous fires, I'm not sure any of that actually fits. I think it's got some issues at least. So, when we think about this, so those of you who know botany or know ecology have probably run into John Curtis's book, Vegetation of Wisconsin, or know him. Curtis, probably better than anyone of his time, or at least as well as anybody alive then, knew fire-dependent plants and communities. He had a deep understanding of ecology. And even when you look in his book, Vegetation of Wisconsin, he struggles sometimes with some of these communities and talks about reversion rather than progressive succession. And so here I've got, we had a site in Wisconsin Dells, actually, that was one of Curtis's sites that he used for data that went into this book. And when you think about his reference point, these are the fires that Curtis would have been aware of probably in his life. And also this is actual fires from one of his sites. Again, his data really was already 50 years removed from an intact fire regime, if there was such a thing. But when we put those, European settlement era fires into the context of a longer history, it really is nothing anomalous at all, at least in terms of its fire frequency. And so I got interested in this question and wrote a paper on it, but essentially this is an expanded data set, many, many hundreds of fire scar samples over all these different ecological landscapes. And I just basically tried to determine, the trend over time in fires per decade. And essentially, most sites, this period of settlement from about 1860 to 1930 or 1920, had a diminished fire frequency in many cases. And we had, I think, 2 sites that had an uptick, and they were both in the Northeast Sands, and they were both unlogged old growth pine systems. So kind of thinking this kind of data, and I know I'm probably kicking a dead horse by now, but I'll be done kicking in a minute here. So I've worked all through the UP with a graduate student and some others, Colleen Sutheimer, who did her master's work at Madison, working with me and Volker Radeloff, and she did some really amazing work. And we combined all these big data sets from fire histories in the middle of the UP and Seney National Wildlife Refuge, from the Huron Mountains that were collected by Mike Stambaugh, Rich Guyette, and others, data that we collected in the Ottawa Forest on the Sturgeon River Gorge Wilderness area, big hardwoods landscape. We sampled, sandy plains, Lake Superior sand dune systems, all these different systems. And essentially what we're finding is that fires were much, much more frequent across all of them than we ever would have imagined. And they were more widespread. And so one of the pieces that Colleen put together was looking at, the climate data. In this case, we're looking at Palmer Drought Severity Index for fires that were synchronous across huge areas of the Upper Peninsula of Michigan. And so the negative numbers are dry, positive are wet. And this is a really simple analysis. It has a fancy name, superposed epoch analysis. But basically we said year 0, the fire year, show me the climate that was then. And then basically we took the 1,000 iterations of random grabs of Palmer drought severity indices and said, compare it to that. And that's what these bars are. And that's how we get these confidence intervals. And essentially what this is showing us is what this graph is showing us, that these large synchronous fire years, some of the biggest fire years we know of in this region were dry. And this is a fire that broke out in a peatland while we were doing our work on fire history of peatlands and in the Hiawatha National Forest. And this was midsummer growing season fire. And I just want to point out that we as the Northeast is lighting on fire or been burning for a while now, New Jersey, Connecticut, New York, etc. This is actually, we could anticipate all of this. And I think we should be anticipating more of it to come. All right. Now, maybe that was a good bridge for what does it all mean? So I'll share that. I'm almost done. So, back to this quote from Leopold, right? What is the mechanism? And so we know the mechanism, or at least we know one mechanism that really spans all these lands, right? Fire. And this is another way of saying what Leopold was saying. This is a paper. This is framed in terms of habitat complexity or habitat for biodiversity or wildlife. And we lack understanding of the mechanisms. And so I think we know what the mechanism is, or at least we know one mechanism that was very important. And that was fire. And so I talked about this, how spatial complexity is so important. And so what we see is that fire creates complexity, and that complexity then changes fire behavior into to favor those species and those systems over time. So it's a self-perpetuating feedback mechanism. And this is some more data that I'm working on now with Elena Rezenkova, who works with me, and we've got a project going where we took all of that spatial patterning data and more of it, including Minnesota, and we basically measured crowns of old growth trees and said, if an interlocking crown is a definition of a group of trees, what is the sort of patterning of these groups? So small, medium, and large groups of trees, individuals, those that are far enough apart. And this is historical data. We basically found that you see all these different configurations at about 4 to 6 meters distance, which is about the mature canopy of say a red pine or a big white pine. And you have large clumps of trees present, individual trees that are far enough away from other trees to be considered individuals, and other size clumps. So you have a really complex pattern. And today, what we find is that even in these reference stands, at just 4 meters, it's all solid blue. At 4 meters, we see one solid forest now. So it's lacking all of this complexity. And so we have a project where we're trying to recreate this complexity and turn a lot of this historical data into silvicultural guidelines called the Northern Pine Management Initiative. And we're doing that. This is a picture not a particularly beautiful picture. The one on the left, you're standing in one of these ICO, individual clumps openings, these complexity harvests, looking into the regular thinned area. And then the picture on the right is one of those clumpy, groupy, irregular thinned areas. And so, we think about this, our method of combating climate change really, a lot of it comes down to planting trees. If you haven't heard of the Trillion Trees Pledge, we'll be hearing about it, maybe more, or you will. Even in Trump's first presidency, he was an early pledger and adopter. Governor Evers in Wisconsin was one of the first states to jump on board in this Trillion Trees Pledge, and we vouched to plant first 75. We've upped it to 100 million trees by Earth Day 2030. And so that's all good, but I think, in the original pledge that we made, we were going to conserve land, and I think we are trying to do that, and we're going to restore land. And that's a big question mark. I haven't heard much about that, but in my mind, we have a huge opportunity to combat climate change, to make our forests more resilient by restoring some of the landscapes we already have. And there's a lot of evidence that fire is a big part of that, not just in terms of spatial patterning, but even in terms of carbon sequestration and carbon storage in these systems, whether it's below ground or above ground. And then we've got a lot of work to do. This is data. When I first started with the Wisconsin DNR, one of my first tasks was to work with this group to come up with what we called the Wisconsin Fire Needs Assessment. And that was basically like a cost benefit analysis of where we have the opportunity to maintain fire dependent communities. And so this isn't to restore necessarily. This is saying, of all the fire dependent communities, where do we have the best shot at keeping them around? And so something that you'll notice here, we looked at 12 different communities. I would argue, having learned what I've learned in some of my research in the last 5 or so years, I would add probably at least a half a dozen more communities on here, if not more. But sticking with this, you'll notice, that, tallgrass prairie and oak savanna, not surprisingly, are some of our least opportunities, because we just don't have many of them left. But we have a lot of different systems that are fire dependent in the state that need fire and opportunity to use it. This other figure that you'll see, this is the spatial part. This is the red area in this map. And I used to shy away from this, not thinking like 1 million acres is just, that's blasphemy. Like it's just too pie in the sky. But, if we think about that, there are a lot of states in the Southeast, in the Great Plains. There's a lot of states in this country that are burning at least 1 million acres, if not twice that per year. Florida, 2 million acre years are not uncommon there. So it can be done. And I've highlighted what 1 million acres in Wisconsin looks like, and it's basically Chippewa County. That's what we need to be doing. Okay, to try to just put a hat or wrap a bow around a lot of information and a lot of things that I've put your way. I would say that, this idea of trees being the answer, I like that, but I think we can't stop there. We have to use fire in these trees, in these forests, and not just protect them from fire. This idea of European settlement fires being an anomaly, I think it's smart to think more critically about that. I think we need to do that in terms of preparedness for what could be coming our way. I think we also need to do that because, to me, the anomaly isn't the fires that were occurring in the settlement era, but really the 100 years that followed without any fire per se. That was probably in part luck. It was probably in part design, but neither of those things are going to work for us, perhaps going forward in the future. Low severity fires are what maintain that complexity and stability. That's our best chance of having the kind of fire we want and the kind of fire where we need them. And so, and it wasn't just limited, to pine barrens or oak savanna or tallgrass prairie. we're talking many different forest types, many different communities. I sometimes get myself into trouble by saying that I think, basically, I would say Wisconsin fits this, and maybe most of North America, that there are two kinds of communities. There's fire dependent communities and there's fire adapted communities. So if a tree or a forest couldn't figure out how to live with fire or avoid it somehow, then it wasn't going to be around long. So we had, I think, a lot more fire in a lot more places than we even know. And I want to end with another Leopold quote. So this is a picture of Aldo Leopold and his students at the UW Arboretum, arguably the birthplace of restoration ecology in this country. And the photo is probably from about the time of the quote, sometime in the 1940s. But he writes, present day problems in conservation and land use, viewed in light of contemporary evidence alone, often baffle the investigator. The same problem, viewed in the light of history, may often be deciphered as the repetition of some historic pattern. And I hope that through my kicking of that dead horse over and over again, that you at least have an inkling of what that historic pattern that's repeating itself may be. Thank you.
Well, that was certainly a lot of information, Jed. Fascinating topic. I always say I get to ask the first question because I'm the moderator. So perhaps you'd like to comment about the Native American use of fire to manage forests before European settlement.
Yeah, well, I'll say I'm not an expert on this area necessarily. I think Native American use of fire is was probably very important for lots of different systems. I think we had a lot of different. I think we had fire starts of all different kinds. And I think so. For example, a lot of the 2023 Canadian Eastern Canada fires, so Ontario, Quebec, the areas we're not accustomed to seeing burn. Human ignitions swamped natural ignitions in those systems, but lightning ignited fires accounted for probably 85% of the area burned, and that's pretty standard. So a lot of what I showed you with like the climate graphs and the big synchronous fires across multiple ecological landscapes, it's highly unlikely that those were by design. They were climate driven events. It's not to say they couldn't have been, but usually when we think of human drivers, they're sort of asynchronous, bottom up, and climate drivers are sort of these synchronizing top down things. And mostly what I've spoken to is the latter, not the former. But I do think Native American ignition was important, and I think it is important. I think we need to be thinking about how to work with the tribes more going forward. I was up with some friends and colleagues on the Menominee Reservation last week, talking about these very things. I think they're at a very different starting point than most Europeans, just in terms of their ecological mindedness and their relationship with fire. We're starting from a very different place.
Correct. So I'll get to the first question I can find here. Karen was interested in the 1894 Phillips fire, and she related that their records locally were 13 people died, and she was interested in where you had your source for the number of people that died in that fire. You said in the hundreds.
Yeah. I spent some time digging into historical archives on some of those better known fire events, including 1894. There were a couple townships in that area of Wisconsin that burned completely over in 1894. And I think, I'm not looking at it now, but I think it was in September of 1894 in Wisconsin. And I had heard it did some damage in terms of human lives. The other thing is, it's really hard, even with the Peshtigo fire, the numbers range from 400 to 1,500 to 2,500, maybe, depending on where you look. So we really don't have good records of even some of the better known fire events. And I do think, yeah, even when you visit the newspapers, you kind of can see some of that inconsistency.
Yeah, for those who might be interested, there are some, we've done webinars, of course, on the Peshtigo fire, and they're available on our YouTube channel. I'd encourage you to go check them out. Don, why don't you ask your question if you're available?
I'm sitting right here. You mentioned the General Land Office records and that there was an extrapolation by tree species. And I was wondering if that extrapolation is available anywhere online for people to view.
Yeah. So the General Land Office witness trees are, I think, completely digitized and available. You'd have to know something about GIS or have ARC or some way to handle that data, I think. But and there are published maps, even printed maps of those witness trees. I have one in my office and I look at it a lot. And I think if you look around, you may find I mean, if you're interested in just seeing it, I think that's easy. If you're interested in manipulating the data, like doing a data poll like I did, I think you'll need some sort of GIS capability, but there are publicly available data.
I think the Natural Resources magazine did an article on David Mladenov's map.
Yep.
That would be one way to look for it, Don. And we could maybe send that out after the presentation because it did a really good job. The article was really nicely done.
Good. Thank you.
So Zach's wondering, can fire help with carbon sequestration, or is it a carbon source?
Well, that's interesting, and it's a big question, but let me just let me scratch it at least. So if you think about the carbon dynamics, and if you know the most obvious is as a high severity crown fire of a forest, right? So you have the fire come through, and it's an emissions of carbon and other gases at the time of the fire. Most of the emissions from that fire, however, will occur decades later. Once those trees are 10 years dead and start to fall over and hit the ground, it's decomposers, it's microbial activity and their respiration that expires more carbon into the atmosphere. The majority of carbon from a fire comes well after the fire. And so, but in those 10 years or 20 years or 30 years that all that's happening, that those things are breaking down, you have new trees growing and putting on, big growth. My point being, you can look at these kinds of data for systems like the 88 Yellowstone fire that my PhD advisor worked on. He's, written about that. But it's basically, if you look at it in terms of the fire regime, the natural fire regime. So in Yellowstone National Park, lodgepole pine, the fire regime is basically you'd expect a fire every 300 to 600 years. Within 300 to 600 years, you're probably sequestered more carbon than you emitted from that fire, or they're neutral. It's a zero sum game. And then so that's one system. Now, if you think about it in terms of, grasslands, most of that carbon is below ground. And so that's safe from fires. Those are really resilient systems. So by having, a wood, like that picture I showed of Upper Peninsula of Michigan, a fire could go through there and it's basically, pyrogenic carbon or partially burned things are very stable. They last a long time. We see them in lake sediments that are 10,000 years old. So that's stable. There's a lot of ways that those systems can actually, by burning them, you increase plant growth, et cetera, and you increase carbon sequestration. One more example, because this is work near and dear to me, and that's peatlands. Peatlands make up about 3% of the Earth's surface and sequester more than 2 times the carbon of all of Earth's forests combined. They are nature's engineer for carbon sequestration and carbon sinks, terrestrial sinks. And what we're finding now, we think of peatlands as being very slow to change, but they burn much more frequently than we ever imagined. And they basically burn like the top few inches of peat. And so again, you have that pyrogenic carbon, which gets eventually into the peat systems and lasts a really long time. You also stimulate new plant growth. If you look at peat accumulation around Earth, and for the last millennia, it's basically you get your greatest amount of peat development was in warm periods of Earth's history. And what places like the Spruce Experimental Station in Minnesota are telling us is that global warming, that warming will turn those peat systems in Minnesota from carbon sinks to carbon sources because it'll increase microbial activity. But it also increases net primary productivity. It makes more green things growing. And there's Flanagan out of Duke University has done some really cool work looking at low severity fire effects on peat systems, and it directly has an impact on microbial activity. So you can do those low severity fires and reduce microbial activity. So anyways, there's a lot to that question, and I love that topic, and that was already long-winded enough, but great question.
Am I missing anything, Don?
I don't think so. There's nothing in the Q&A, and we have a couple compliments. Great presentation. Glad to be able to watch this again. It would take more than one watch to totally understand all the information that was given. So nice compliments, though.
I did want to say one thing. You had a lot of information about the Northern Highland ecological area, and we're going to be doing our annual meeting next year on the Northern Highland American Legion State Forest. It's its 100th anniversary. And one of the things I had in my mind to visit was some of these areas where they had historical fire, and you can see the fire scars on the red pine trees. I've been to several of those myself, and they're fascinating places to visit.
Yep, they are.
All right, Don.
All right. Well, thank you, Jed, for a great presentation. All the information you gave was new and exciting information for most of us, or many of us, and so that's great. We hope everyone that participated tonight enjoyed and learned something. And I have to remind everybody again that at the end of the webinar, when we close down, you'll be sent a survey. It's just a 7 or 8 question survey. It takes a short amount of time to fill it in, and we really do appreciate it if you could fill it in. Our next webinar is scheduled for December 18th. That will be Dr. Amy Rosebrough from the State Historical Society, and she will be talking about the ghost ports of Door County. Again, the webinar is free, but pre-registration is required. You can find additional information about that on our website, the Forest History Association of WI, and registration, as I said, was required. The webinars are recorded, and they're usually posted by tomorrow morning or the next morning, and available on our website and our YouTube channel. So with that, thanks for joining us. Jed, thank you again for a great presentation, and everybody have a good night.